Good morning, everyone. Welcome to the session. My name is Jayaraman. I work for Brocade, and I've been an active contributor to the Tacker project, and this is one of the topics related to that particular project. So I have my co-presenter Kanakaraj called out here, but unfortunately he was not able to attend the summit. So I'll be driving the entire presentation and the demo. So at a high level, the topics I plan to cover are, for most of you that are not familiar with Tacker and NFV, I plan to give an overview of Tacker, an overview of NFV at a high level. Then I plan to take you through what we delivered in Tacker as part of the Newton release, how it actually helps with meeting SLA when using VNFs and Tacker. And finally, I will actually play a demo video that I have to end the session. So Tacker is an official OpenStack project that supports NFV orchestration and VNF manager based on standards architecture like HCMano. So Tacker was started early in 2015. It was announced at the Vancouver Summit. In the Kilo release, we had the basic VNF, the VNF management capabilities. In Liberty, we added support for basic monitoring framework features. In Mitaka, we got accepted into the big tent, and we officially became part of OpenStack project. So we have about 6 core reviewers. And as you can see in this slide, we have a diverse community of developers from different companies contributing to this. So that was the high-level overview of the Tacker project. For those of you not familiar with NFV, NFV is a new way of designing, developing, and deploying network functions using the virtualization technology. So this allows for decoupling your network functions from the underlying proprietary hardware, so which actually enables to accelerate deployment of your VNFs and also reduce your CapEx and OpEx costs. So that's about the NFV overview. So today, this is what the NFV, the Tacker architecture slide looks like at the end of Newton Summit. So like I said, we have the NFVO component and the VNFM component, and I'm going to be focusing on talking about the VNFM component. The pieces in the box are the event audit log and the alarm monitor that you see at the bottom, and one other feature called VNF scaling that is not called out here. So we'll talk about that. The scenarios that we are trying to address with these features that was delivered in Newton is, how can we actually provide a mechanism for notification when you have the different Tacker resources undergo some lifecycle change events, and how that could be actually used by external applications for remediation. And the other scenario would be how an operator could actually use the same for auto remediation when peak load conditions occur and still be able to meet the SLA. So the features, like I said, that is part of the Tacker release in conjunction with some of the OpenStack existing services like Eleometer that could be used for these 2 scenarios are one from Tacker itself, the lifecycle event logging. And from OpenStack services, we're going to be leveraging Eleometer. And then Tacker has got scaling, VNF scaling, and also alarm monitoring capabilities. So we're going to use this to talk about the 2 scenarios I just previously talked. So Tacker, as part of Newton, has provided a framework wherein any Tacker resource that undergoes any lifecycle operations gets recorded in a database table, which in turn can actually be streamed further to other external third applications that can actually process it and take any action or a remediation action if needed. So a case would be if a VIM is probably unreachable, and if that status notification goes out, there could be some sort of a remediation to go and fix that issue. So that would be one. So we currently have support for, like I said, VNF, VIM, and VNFD. And we also have VNFFG and other resources being supported that will also be enhanced to support this. And Eleometer is one of the OpenStack services that we try to leverage. Most of you know that Eleometer is part of the telemetry project, and it helps with gathering physical and virtual resource utilization. It normalizes data and allows you to analyze it and be able to, in conjunction with EOD, you'll be able to trigger actions based on when certain conditions are met. So that would also be something that that can actually be used in conjunction with Tacker for auto remediation and for meeting SLAs. So this is a quick slide. So we now have scaling capability implemented in Tacker. What this means is Tacker supports Tosca VNFD, which means an operator should be able to go and specify in their VNFD certain scaling policies. You can actually specify multiple scaling policies within a VNFD, and which would actually be invoked either manually through the Python Tacker client, or if used in conjunction with a monitoring framework, it can be invoked automatically as well, which again could help with meeting SLA. And the other feature in Tacker that we have as part of Newton would be the alarm monitoring capability. So this actually allows for monitoring CPU and memory usage in the VNF components. You can actually specify this monitoring policy, again, Tosca-based VNFD that actually will be instantiated. And this can be applied to either single or multiple VDUs. So this, when used, you can also specify Eleometer alarms to help with triggering auto scaling. So this is the piece that can actually help you with auto scaling. Next, I will actually share with you guys VNFD sample, VNFD template. Okay, so this is if you use scaling and alarm monitoring, this can actually help you with the auto remediation. This is to illustrate that. And next time, actually, before I go to the demo, let me share the template that actually can help with scaling, and also monitoring when used in conjunction can help with auto scaling. If you see on the right-hand side, there is defined policies, SP1, which is a scaling policy, that can actually be invoked from the monitoring policy that has been defined. So in this, the scaling policy here is targeting a certain VDU. In this particular case, we have only one single VDU. That when this particular VNFD gets instantiated, it actually gets, it'll actually have two VDUs by default, and it can scale up to 3 total and can scale down to 1. And this can actually be invoked by the monitoring policy that is down at the bottom, which actually is which is monitoring the CPU utilization. In this particular example, and for the demo, I'm using a 10% utilization, and for 4 minutes. So let me jump right into the demo. So the template that we just saw is uploaded here. And if I look at the properties of the template, the scaling policies, and the monitoring policy, you can see that they're the same here. So what I'm going to do is, I'm going to actually, once I upload the VNFD, I'm actually going to the host, and the command line that you saw was actually to see if there's any Eleometer alarm that was created. It wouldn't be created until actually the VNF gets instantiated. So next, I'm actually deploying the VNF here. Of course, this is an accelerated video. So here, we will see that it goes through some state life cycle changes like pending create to active, which can actually be captured as part of the VNF by going to the events tab. In this particular case, 2 VDUs are being created like I showed in the VNFD. And as a part of this creation, these are the different state changes it goes through, which actually can be streamed to an external application if it subscribes to, and they can take any remediation action if required. So in this case, it goes through a create, monitor, and finally to an active state. And if underneath it uses eat. If I went to the eat stack, you should be able to see that the corresponding resources are being created. Like the key is that the scaling policy, the alarm, the scale in, scale out, which could be either invoked manually or automatically, is there. And there's also the alarm being created. So now when I come back and see if there's a Eleometer alarm created, yes, it will be, because from the VNFD template, we have instantiated a VNF, and the alarm is there. And it will get triggered when a certain load conditions are met. So I showed htop on the host to show before loading the VDUs what it looks like. And next, I'll log into those VDUs and apply some stress script that actually loads up the VDU, and actually it goes through a certain period, in this case 4 minutes of 10% load on the CPU, just for the sake of the demo and for demonstration, and it triggers the alarm. That's what will come up next. So running that script, which actually helps with the loading of it. So if you now go to the host and runs htop, you'll see that it is being loaded. So once it goes through a 4-minute time where it's 10%, it's the threshold, and it'll actually start the scale out action. So if we then go to the events tab, we'll see that there are new events being created. There's an auto scaling that's been invoked, and it's at this time it's pending scale out, and pretty soon it'll go to active, and the scale will be done. So this is what we have as part of the demo to demonstrate that with Tacker, operator can actually use this capability to be able to have auto scaling and help meet the SLA. So thank you. This is